This is the last video of this series about pfSense and UniFi Layer 3 switches. In previous videos, we configured the network in the way shown in this diagram. We have two VLANs managed by the first UniFi Layer 3 switch, another two VLANs managed by the second one, and we have a VLAN 10 which is managed by pfSense. Of course, we have other computers, devices that also need to have IP addresses. For example, this UniFi network controller. This is the subnet situation in our test network environment. Each UniFi VLAN has its own subnet. For example, the first one, subnet 111.121 for this UniFi switch, 131, 141, and for pfSense 10 subnet. The two UniFi switches and the UniFi network controller, they are in the LAN part of pfSense, so they have the default 1 subnet. However, the way they get IP addresses are different because there are multiple DHCP servers in this network. Let's revisit the DHCP settings in UniFi Network Controller. Let me go to Settings, Networks, click on a UniFi VLAN as an example, such as VLAN 121. In the Advanced setting, in the DHCP section, you can find the DHCP mode is DHCP server. As explained in previous videos, this DHCP server is the built-in server within the particular UniFi Layer 3 switch. In our case, Pro 24 switch for VLAN 121. It's not the DHCP server in pfSense. You may ask why here Ubiquiti cannot simply let pfSense handle the DHCP request. That's simply due to how DHCP works. Let's check the network diagram. When this particular Linux machine, the Linux number 2, a DHCP client, when it tries to request an IP address through DHCP, it doesn't have an IP address yet, of course. So it can only do network broadcast to request IP address. The way broadcast works is the broadcast message can only be received by machines in the same subnet. If you check the subnet settings for VLAN 121, you can see it's in the 121 subnet. Before we introduce VLAN 121, this particular Linux machine is in the same subnet as the LAN interface of the pfSense, so it can acquire IP address from the DHCP server in pfSense without problem. But after the subnet is changed to 121, the DHCP server in pfSense cannot receive its request anymore, so cannot provide IP address to this particular Linux machine. Therefore, the Layer 3 UniFi switch comes with a tiny DHCP server to provide IP addresses to the machines within its own VLANs. For the same reason, the second UniFi Layer 3 switch also has its own DHCP server and is up and running. At the same time, we still have DHCP server running in pfSense, providing services to LAN and VLAN 10 interfaces. Let me show you. In pfSense, go to Services, DHCP server, and you can see we have DHCP server on LAN and VLAN 10 interfaces. We have 3 DHCP servers running in the simple testing network on pfSense on the two UniFi switches. This is a nightmare for network management. You don't have a single place to have the complete picture of the IP addresses, about the pool configuration, and about the runtime allocation information. To resolve this, here comes DHCP relay. This is the DHCP article from Wikipedia. In the relaying section, you can find the DHCP relay agent information. It talks about why DHCP relay is needed and how it works. If you are interested, you may want to take it as a reference. In this video, let's directly jump to the configurations. Let's go back to UniFi Network Controller. In the VLAN configuration page, for example, for VLAN 111, go to Advanced menu under DHCP. So if you pull down this option, you can see another choice. It's called DHCP relay. This option was not supported when UniFi initially released the inter-VLAN routing support for UniFi Layer 3 switch, and it was a showstopper for many people to adopt this Layer 3 routing feature. Later, Ubiquiti added the support for DHCP relay. So let's see what additional information is needed if we choose DHCP relay. The only extra information needed is the DHCP server's IP address. An external DHCP server is required for DHCP relay to work. You may think, okay, it's not big deal. We have pfSense, and pfSense comes with DHCP server, doesn't it? Let's take a look at the DHCP server in pfSense. In pfSense, go to Services, DHCP server. The way DHCP server configuration works in pfSense is you configure the DHCP server for each interface separately. For example, let's check VLAN 4040. Of course, currently DHCP server on this interface is not enabled, but if you scroll down, see the subnet is this subnet, and you cannot change it. This subnet information comes from your interface configuration. And then see the available range. The range must be within the subnet. And then later, whatever you want to add when it comes to range, it has to fall within the subnet. If you want to provide service for our VLAN 111, right? So let me try to add a range here. So let's assume this is the range we want to provide a DHCP server for the subnet 111, right? If you try to save it, see, you will get this error. The specified range lies outside of the current subnet. So the subnet limits the range you can support. Because of this limitation, I am not aware of a way to make the DHCP server on one interface support multiple subnets in pfSense. Even though we all know for sure the underlying DHCP services on the operating system level, it must support multiple subnets. But the user interface simply doesn't allow it. If I miss anything here, or you know a way to do it in pfSense, let me know in the comments area. Because of this limitation, I cannot use the DHCP server on pfSense to provide services to DHCP relay in UniFi Layer 3 switches. The way I resolve the issue is to run a dedicated DHCP server outside of pfSense. Many people prefer a DHCP server running on Windows server, but this is just my lab environment, and I like the simplicity of DHCP server on Linux, so I simply set up a DHCPD on a Debian Linux. I will not waste your time talking about how to install the DHCP server on Debian Linux. You can do your own research if you are interested. It's very simple. Let's directly check the configuration file in Linux. In Debian Linux, let me run this command to show you the DHCPD configuration file. Make the font a little bit bigger. Scroll to the end. Okay, there are already 6 subnets defined. For now, let's focus on the first 4. These are for the 4 VLANs defined in the UniFi Layer 3 switches. VLAN 111 to VLAN 141. 4 of them. For each of them, the configuration is super simple and very straightforward. Let's take a look at the first example, the subnet 111. This is the subnet, net mask, very easy. The range, I just put this 100 to 200 as an example. You can define it to anything you want. When it comes to the option section, I only specified the routers for each subnet. There is also no surprise here. It is the expected setting. And so far, the DHCP server configuration is very easy. Let's finish the UniFi network controller side setup to enable DHCP relay. Go back to UniFi network controller. Under network setting, let's start with VLAN 111. Go to advanced setting for DHCP. Change the DHCP mode to DHCP relay. And here we need to provide the DHCP server's IP address. In our case, we want to use the Debian machine's IP address. By the way, for the Debian Linux, we cannot set it to get IP address from DHCP server anymore because it is DHCP server itself. So if we go to the network configuration under IPv4, you can see I set it to menu and give it a menu IP address. Okay, we get the IP address. Then let's go back to UniFi network controller, fill the DHCP IP address. Okay, then click add button. It's added. User interface is a little bit confusing here. The DHCP IP address is shared among all the layer 3 switches. You will see what I mean later. But for now, we are good. We already added the DHCP server here, right? Okay, we are done with the change for VLAN 111. Apply changes. Now move on to VLAN 121. In the same way, change DHCP mode to DHCP relay. Now you can see what I mean. So the .1.118 IP address appear here automatically. That's what I mean by it's shared by all the UniFi switches. So you don't need to import it again. Simply click on apply changes. And in the exact same way, let me quickly finish VLAN 131 and 141. Okay, so now we are done with the UniFi network controller changes. We need to force the 4 Linux machines to refresh DHCP so that they will acquire IP address from the new DHCP server we just specified instead of from the UniFi layer 3 switches. Let me use the Linux number 4 as an example. To make sure the IP address is changed after the refresh, let's first get the IP address before the change. Okay, you can see it's .141.6. That's the first IP address we set in UniFi layer 3 switch DHCP server, right? So that confirms the current IP address was acquired from the UniFi network controller. Then let me go to the network setting, disable wired, enable it again. See, the icon is changed. Let's run the same command again. See, this time the IP address changed to 141.100. If you check our DHCP server setting, you can see for subnet 141, the starting IP address in the range is 100. So this confirms, okay, now the DHCP server is the one we want it to be, and the DHCP relay in UniFi network controller works already. Okay, so in the same way, I will refresh the other Linux machines. From the Linux number 1, the VLAN 111 Linux machine, let me ping VLAN 141, the Linux number 4 machine. It is in another layer 3 switch. Let me ping it. Yeah, it works. Then let me ping an internet domain. Okay, it also works. So we have confirmed that no communications are impacted after the DHCP configuration changes. We are not done yet because we still have DHCP server running on the pfSense. This is the current DHCP server and DHCP relay situation in our test environment. The DHCP relay is already up and running in both UniFi layer 3 switches, and the dedicated DHCP server is also running. It's serving 4 subnets. However, the DHCP server on pfSense are still there and providing service to subnet .1 and .10. It may not be a good idea to have 2 DHCP servers running, even though at this moment these two, they are not really conflicting with each other because you can see the subnets they serve, there's no overlapping. But I still don't like it. I want to change it. So I want to stop the DHCP server on pfSense. However, the 2 DHCP servers are there for legitimate reasons. We do have devices on subnet 1, for example, the 2 UniFi switch, this UniFi network controller, and we also have Linux machines under VLAN 10, right? So they need DHCP to acquire IP addresses. To address their needs, we can use the DHCP relay feature in pfSense itself. In pfSense, go to Services, DHCP Relay. You will receive this error. If you have DHCP server enabled, you cannot enable DHCP Relay. It makes sense, right? So we need to first disable the existing DHCP servers on pfSense. Go to Services again, choose DHCP server. Then we need to disable them one by one. So for LAN interface, disable it, save. For VLAN 4040, we don't have it enabled anyway. For VLAN 10, disable it, save. So now let's go back to DHCP relay. Yeah, now we have it ready. The configuration is super simple. You simply enable it. Theoretically, the interface selection here does support multiple selection, but for unknown reason, I'm not sure whether it's the Firefox bug or the Linux bug or the pfSense bug, I don't know, but I cannot select multiple individually. I can select all of them by clicking the shift button. But the side effect is I will include the VLAN 4040 because it's in the middle, right? It's not a big problem because we know for VLAN 4040 we don't have device to acquire DHCP service. So let me make the setting in this way and then scroll down. For the destination server, IP address for our dedicated DHCP server, right? Choose this IP address, save. Yeah, it's up and running. Now let's go back to the DHCP server configuration in Debian Linux. See the very last two subnets which we skipped previously. Now let's take a look. So they are for subnet 1 and subnet 10 respectively. The other part, the router setting, the range are similar as previous for VLANs, so we are good. Now let's use the Linux number 5 in VLAN 10 to validate the pfSense DHCP relay setting. Before the refresh, let me get the IP address. Okay, you can see before the refresh, the IP address is 10.100, right? So now let me force the DHCP refresh. Now let me run the same command. Yeah, you can see now the IP address is 10.150. Why 150? If you look at the right side DHCP server setting carefully, you can see I deliberately set the starting IP address as 150. I just want to make sure we get the IP address from the new dedicated DHCP server instead of from pfSense. So this change confirms that, right? We get the 150 IP address. So now from the Linux number 5, which is under VLAN 10, let me ping the UniFi VLAN, for example, VLAN 111. 111.100. Yeah, the ping doesn't work. Why? If you remember in our previous video for UniFi VLAN versus pfSense VLAN, in the firewall rules for VLAN 10, we only enabled the access to subnet 141. So that's why here, if I ping subnet 111, it will fail, right? Let me change it to a 141 IP address. Okay, this time it works. This is the final picture of our DHCP settings for our testing environment. You can see now there's only one DHCP server in our network. It serves multiple subnets, and on each UniFi layer 3 switch, we run DHCP relay, and on pfSense, we also configure DHCP relay. Depending on the DHCP server we use, we may have monitoring functions. For example, in my case, if I want to know the allocated IP addresses, I can simply go to the Linux machine for DHCP server. For example, I can run this command just to display the DHCP list. It shows me when which machine lists what IP address. Okay. This is the end of this video, also the end of the whole series, totally 5 videos about pfSense and UniFi layer 3 switches. Thanks for watching.